Hello everyone, this is Ahmed Jahaz again, emergency response and fire protection specialist, and today I have the topic of the one of the fixed systems for foam fixed systems for storage tank fire protection. So today is the regarding the top injection foam systems, where we inject foam through a system that will enable us to pour or to put foam on top of the burning liquid, as you can see here. Foam will be injected through the system. A foam solution will be injected through the system until it reaches the foam chamber on the top here. And the foam chamber will have a facility to introduce air to the foam solution in order to produce the finished foam or the expanded foam or the firefighting foam before it enters to the tank and floats on top of the burning liquid inside. So these type of systems comes either in a semi-fixed system or a fully fixed system. Fully fixed system means that the foam solution, the foam supply is pre-attached to the system and connected. We don't need any interference from the emergency team. As for the semi-fixed system, means that the foam concentrate must be transported to the system or to the tank via fire trucks, or foam tankers or fire apparatus, and must be connected by the emergency team or the people in charge. So where can we find the foam chambers installed on the tanks? Whenever the tank is a fixed roof tank and storing either hydrocarbons with high viscosity or polar solvent and alcohol-based liquids, because these type of liquids are destructive to the foam, the firefighting foam, and can interfere with the formation of the foam blanket if injected or mixed with the fuel. So we need to have it poured on top of the tank. We don't want to mix it with the fuel. Otherwise, it's going to be a mess and it will ruin the formation of the foam blanket, and a lot of nasty things will happen, and maybe it will complicate the situation. So, one bit of information I would like to add is that normally fixed roof tanks will store combustible liquids. These are liquids that have flash point based on NFPA 30. These are liquids that combustible liquids are liquids that have flash point at 38 degrees Celsius and above. Versus the flammable liquids that are stored in normally stored in floating roof tanks that have flash point below 38 degrees Celsius. These are very important information that for people that are planning or in the profession of planning for emergencies, and they need to know and differentiate between the classes of flammable and combustible liquids. Also, the type of liquid is very important to know, be it a normal hydrocarbon or a polar solvent or alcohol-based later on, you will see that these factors play an important role in fire protection, especially in our industry. It will play a role in the application time of the foam, the type of foam used, the type of system, the construction of the tank, and things like that. So it's very important to know these things, the flash points, the boiling point of the liquids, the type of the liquid. Is it soluble in water, or is it a hydrocarbon? Is it not? So polar solvents and alcohol based that can ruin the foam, and it will soluble with water. It will mix with water and break the formation of the foam. So these are important information to know. So as per NFPA 11, in order to calculate the total system supply or the supply needed for a certain system, we need to calculate the primary foam supply, the foam supply for the primary fire protection, primary system, and we need to have some kind of supplemental hose stream supply. So how to calculate the primary supply? We need to know the surface area of the burning tank. So in the shape of a circle, so we need to multiply by the radius squared of the tank, radius of the tank squared. And we need to know the application rate. The application rate depends on the method of application. Is it a fixed system? Is it a top injection or subsurface? Then the minimum application rate will be 4.1 per minute per square meter. Then we need to know the application time. What is the application time? Well, the application time depends on the type of fuel and the application method. If in this case, when using a fixed system, we know that the application rate is 4.1 liters per minute per square meter. And as for the application time, it depends. What is the type of material? What is the class of the material? Is it a flammable or combustible? If it's a combustible, then the minimum application rate would be 30 minutes. If the flash point, if the liquid flash point is below 38 or stored at its flash point, then the application rate will be 55 minutes of application rate minimum. Crude oil storage tank will have application rate of 55 minutes, and also products that are polar solvent or alcohol based will have an application rate application time a minimum of 55 minutes. As you can see, whenever the flash point is lower, you will see the application time is higher. Of course, in the later videos, later we'll be discussing the subsurface injection system, and also we'll be discussing the manual application of foam, where you can see the application rate are different and the application times are a little bit different. So when we calculate the primary foam supply, the foam supply for the primary fixed system, by multiplying the surface area of the tank by the application rate, by the application time, by the percentage of the foam concentrate, because foam concentrate comes with different percentages, 1%, 3%, 6%, and 9% that I know of. We need to have, depending on the concentration, the percentage of the foam concentrate, we will multiply the percentage of the concentrate by the surface area, by the application time, by the application rate, and we will come up with the minimum amount of foam concentrate required for primary protection for the actual fixed system. NFPA also tells us that we need to add the a supplemental hose stream for the system. How can we do that? As you can see from the table on the bottom here, it depends on the tank diameter. Whatever the tank diameter is, it will tell us how many supplemental hose streams are required, and as per that number, we need to multiply it by the minimum operating time. So let's say if the tank is under 10 meters in diameter, then NFPA 11 tells us that we need to have only one supplemental hose stream of 190 liters per minute, and we need to multiply it by the minimum operating time, which is, as per this table from NFPA, is 10 minutes. So we need to multiply 190 by 10, which gives us 1900 liters of foam solution per minute. And also we need to multiply that number with the percentage of foam in order to give us the foam concentrate that is required. So by that, we will calculate the supplemental foam requirement, and we need to add it to the primary the foam requirement for the primary fire protection system. Added together, this will give us the minimum amount of foam concentrate that needs to be available at any certain time within the facility in order to tackle the scenario that we just calculated for. Normally in our industry, what we do pre-plans for each and every tank, which will be useful for emergency responders and especially incident commanders to pull up and know what are the minimum or the resources required, the manpower, firefighting agent, appliances, apparatuses, and equipment required for a certain scenario, and what are the precautions and mitigations. This document will have these information and these numbers and these form requirements included in it for every and each scenario that poses a risk within the facility. However, in order to have the required amount of foam, we go to the worst case scenario that is the most demanding in terms of foam concentrate. The worst case scenario that demands the largest amount of foam required for a scenario, for a credible scenario. Based on that scenario, we need to calculate the foam. So in this case, yes, we can do for each and every equipment, and that's good to do, and we must do it and have it as a resource accessible for emergency responders and incident controllers. However, as for calculating or acquiring the minimum concentrate foam for any at any given time that need to be available within the site and under the utilization of the emergency team at any time, we need to go to the worst case scenario that's most demanding for in regards to firefighting foam, and we need to calculate the amount of foam for that. Whatever the amount of foam that is required for the worst case scenario, this is the amount of foam that must be available at any given time within the facility. So that's it for the foam injection system. I hope you find this video informative and useful. If you did so, please share it with your friends people who are interested in this subject. Subscribe to the channel, give us a like, and drop your comment in the comment section. I try to keep it brief and to avoid details and just to give the conclusion. Otherwise, if you have any questions or any inquiries or any feedback, please drop it in the comment section. I will be happy to reply at the soonest. This is Ahmed Jahaz, over and out.